So this paper is looking at inflation targeting, and luckily this is a very relevant topic for India, it seems, because now we are into inflation targeting regime. I don't know the exact details of how this will work, but the recent budget has, as all of us know, talk about Indian Central Bank incorporating this strategy. So inflation targeting is, as you know, is one of the most important or most widely used monetary policy strategies across the world, and the history goes back to the New Zealand, where they started this monetary policy regime in 1990. That was the first central bank which started it. So the inflation targeting is the central bank publicly announces the target, and the idea is that they would achieve the target over medium to longer horizon. And usually they publish the forecast and the time horizon. So and there are set of industrial countries and quite a few emerging market countries and developing countries. It became very popular in the Latin American countries in the 80s, in the 90s, because most of the countries in Latin America, they were affected by very high inflation. There are also implicit inflation targeting countries, and US is of course one of them. So right now, if you include India, then 28, but the data that we have, 27 explicit inflation targeting countries in the world. So what do they do, and what is the idea behind inflation targeting? Well, the first idea behind targeting the inflation targeting is that this regime, if it works, it's a nominal anchor. So it's anchor inflationary expectations, builds central bank credibility, and in terms of building the credibility of the central bank, it avoids business cycle fluctuation. And if you have divine coincidence, then you also have basically you avoid the business cycle fluctuation, and of course it increases transparency. So let me show you these four graphs, and the vertical line is the date of adoption of inflation targeting in these countries. So there are 3 countries which has explicit inflation targeting regime in place: UK, Canada, and Turkey. So 2 of them developed, 1 emerging. And as you can see, after the adoption of inflation targeting, inflation has become much less volatile, and level of inflation has also gone down. But if you look at China, for example, I'm just giving an example. We have many more countries in the non-IT regime in our sample, but there also the inflation declined. Now, the question is, does inflation targeting work? So how do we measure the effectiveness of inflation targeting? Is it successful? And the literature is, there are tons of papers trying to get into that question, and one strand of literature tends to suggest that IT regime is successful in reducing the inflation and inflation volatility. The other strand of literature suggests that no, it's not. There is no significant difference between the inflation targeters versus non-inflation targeters. So in particular, there is Ball and Sheridan, for example, looked at inflation targeters and non-inflation targeters, and they said that it does not matter. And our paper is closer to Lean and A, and I'm going to tell you how it is similar. So the problem with the existing literature, and I think Apoorva's paper was a precursor to what we are doing in this paper. So there is this, of course, self-selection problem that the countries who adopt inflation targeting, they self-select into this regime, right? So the papers that have found, the argument is that the papers that have found that there is a significant difference, it's because these countries are self-selecting, so there is this bias. So, so what do? You try to get a random assignment. It will try to solve the problem, right? So you can test the effectiveness by looking at the difference between the simple means, and the one approach that people have used is the treatment effect literature, comes from the medicine literature, where you try to find out what is the treatment effect. So randomization is not feasible in our case. So what do? We look at the propensity scores. Now here the problem is that the usual, we are arguing that the usual propensity score method is also not very good because it has some problems. So what are those problems? First is that the parametric specification of the model. So in the propensity score, what you do is that in first stage you estimate what is the probability of adoption of inflation targeting, and then you match the countries that have not adopted inflation targeting with the countries that have adopted, and you try to find the best match. So in the first stage, you need to find out the probability of adoption targeting, probability of adoption of inflation targeting, and then you try to find the match. So we say that there are problems with both of these steps. The first step, which is you have to specify, say, a logic model and come up with the estimated probability, and the parametric model that you have may be misspecified. So we take into account this model misspecification problem, and so as a result you can use the non-parametric series propensity score, and there is a paper by Hirano, Immens, and Reader. So we use that approach. But then there is also a problem with the non-parametric approach, because usually you run into the curse of dimensionality. So what do you do with that? So to get rid of that curse of dimensionality in the non-parametric propensity score, we use a recent paper that proposes a semi-parametric single index propensity score. So what do? In the first stage, we also, in addition to the papers that have considered this inflation targeting in the literature, they have only looked at lagged inflation openness and money growth as the conditioning variables. So to calculate the probability of adoption of inflation targeting, the set of conditioning variables that will predict the probability of adoption, these are the only three variables that they have looked at. So in addition to that, we are also looking at some other conditioning variables. So we are looking at financial development indicators like central bank asset to GDP ratio and private credit to GDP ratio. So in the first stage we are doing that, and in the second stage, in addition to just looking at inflation and inflation volatility, we are also looking at sacrifice ratio, for example, and some volatility measures like exchange rate volatility and interest rate volatility. So basically the question we are asking is, once you take into account the econometric problems associated with the relevant literature, what is the impact of adoption of inflation targeting on inflation volatility, sacrifice ratio, exchange rate volatility, and interest rate volatility? That's what we are trying to do. So I'm not going to look at that, but the empirical setup is that we have 98 countries, and there are 27 targeters, 71 non-targeters. There is a missing data problem as well, and we use a Bayesian method to calculate the missing data. And we also divide this sample into developed versus developing economies. And as I said, in the first stage, to calculate the probability of adoption of inflation targeting, we are using different central bank asset to GDP ratio and the private credit to GDP ratio. So what we get here is, in the first stage, we have this result. So basically our left hand side is the probability of adoption of inflation targeting. So we have the first column is the full sample, the second column is the industrial economies, and the third column is the developing countries. So here we find that, so there is a negative coefficient on GDP growth. It basically means that if you are doing well in terms of high GDP growth, the probability of adoption of inflation targeting is low. Similarly, high money growth countries, probability of adoption of inflation targeting is high. And countries with high credit deposit ratio has higher probability. And openness, so if the countries which are more open have a lower tendency to adopt inflation targeting, which is consistent with the literature. So then we go to how do we, so there is this matching issue, this propensity score matching that Apoorva was talking about. The problem, there are problems with that approach as well. The problem is that in the propensity score matching, you have to make sure that you have a good match, and as a result, you throw off quite a few observations. So to take into account that problem and some other econometric issues, we use propensity score weighting, where basically what we do is that we use weights as the inverse probability of adoption that we are calculating in the first stage. So basically we are trying to mimic a population where it's like saying that you give a telephone call to get the data about unemployment, and only older population is responding, and the younger population is not responding. So what do you do to take into account that problem? Because you have to mimic a population, so you are going to underweight older age population and overweight the younger survey respondents. So that's what we do. That is the propensity score weighting. So here the benefit is that it retains most countries in the outcome analysis, and it does not need outcomes should be continuous and normally distributed, and it also enhances internal validity rather than external validity. So what do we get? The parametric estimate, that average treatment effect, we find, I mean that's the literature, the parametric propensity scores, is that for the full sample, there is a significant reduction in inflation if you adopt inflation targeting. And but if you break that into industrial and developing economies, the impact on developing economies is lower but insignificant. We also find that the impact on debt, which is debt to GDP ratio, is there is a significant improvement in terms of better fiscal situation in the countries that have adopted inflation targeting. And in a sense, you can argue that it may be due to the fact that the government is cooperating with the central bank in terms of promoting the credibility. But we don't find a significant impact on the sacrifice ratio, though the signs are correct that there is a decline in the sacrifice ratio if you adopt inflation targeting. So these are the parametric version of the model, and we are using data till 2014. We find that for exchange rate volatility, for example, we find that there is an increase in volatility in industrial countries, whereas the volatility in the exchange rate decline for developing countries. And for inflation volatility, you find that the impact is much larger in the developing countries. So what we do is then we go and do the non-parametric propensity scores, and this is the result for the non-parametric propensity scores, and you can see that the results are different than what we reported for not most of them, but quite a few of them. And here we find that the impact on inflation is insignificant. What we find is that the impact on volatility measures are much more stronger as compared to the parametric version. And then we go on and look at the semi-parametric single index models. I'm not going to go into the detail, but the idea is that you have the combination of the non-parametric and the parametric version. And here the result that we have is that overall the impact on inflation is insignificant, but in terms of the fiscal situation there is an improvement, but the improvement is much larger in the industrial economies. Sacrifice ratio, again the impact is insignificant, and as compared to the parametric version, we are finding that there is an impact on inflation volatility which is significant for both the industrial and the developing economies. And exchange rate volatility, they are working in the opposite direction in industrial versus the developing economies. So overall, what we find is that The finding based on the semiparametric estimate, it shows that IT significantly reduces inflation variability, and this reduction is much larger in developing economies. And we don't find a significant impact on level of inflation. But I would state that result with a caveat here is that the literature that has done this, looked at this issue, they have found that for developing economies, the impact on level of inflation was significant. It has reduced the level of inflation. But the problem was that they were using data till only 2004, 2005. Now, if you look at the behavior of inflation across the globe, what has happened over the last 7, 8 years, if you leave aside some countries, that inflation has become much more global. So the addition of these 7, 8 years of data, what it has done in our sample is that the difference between the targeters and inflation, non-inflation targeters, what it has done is that it has reduced, and in fact it has made it insignificant. So that may be driving the result for the level of inflation. But we are still getting a significant impact on volatility of inflation, which is much larger in developing economies, and also we are getting results for exchange rate volatility, and I would like to see some of the comments for that, because we are a little bit having a harder time in motivating that. And we also find that the semiparametric model does the best job in terms of model specification and the results.
So I enjoyed reading the paper, and I'd just like to quickly summarize the paper. So the purpose is to estimate the treatment effect of inflation targeting. The data they've used is from 98 countries from 1992 to 2013, 27 IT countries, 71 non-IT countries. The methodology is they calculate the propensity score, they match based on propensity score weighted model, and then they calculate the ATT. The results are that inflation targeting significantly reduces inflation variability, improves fiscal discipline, reduces real exchange volatility in developing countries, but increases it in developed countries. The caveat is that the results are sensitive to the choice of propensity score estimates. The key contribution of the paper is that they account for self-selection, unlike some of the earlier papers and earlier literature which used plain event study methodology or before-after difference in difference regressions to study this question. So this is an improvement. They also account for possible specification errors by conducting semi-parametric and non-parametric estimation of propensity scores. But I would like to add that slight modifications in the estimation, if it changes, it shouldn't change a robust result. Third, they include financial market development variable as a precondition for adopting IT, which has been missed by other papers. And they also study the impact of inflation targeting on interest rate volatility, exchange rate, and fiscal discipline. So these are the key contributions. My main comment is that there is a time dimension which is lacking in the paper. So first, a country adopts IT. It is a transition, and this transition, like I was speaking in the export paper, can be exploited, right? So it's important to understand what is the question, like are we trying to establish causality here? Because then this transition can be used for that purpose. Now there is also wide literature on preconditions of adoption of IT. Now this is different from continuing to do IT. So if we can get clarity on what is the question, that will drive the research design. For instance, in the logit, do you want to take the LHS as 1 when the country adopts IT, or do you want to take the LHS as 1 as long as the country is doing IT? So that comes from the question and clarity on the question. Going forward, there is a tangible difference between de facto and de jure adoption of IT. So for instance, for India, will you consider that India adopted IT a week ago or 1.5 years ago when there was de facto inflation targeting? So before you design the logit model, these questions need to be answered. And once you have a good propensity score using the logit model, then I think you should focus on same year matching, which will help in controlling self-selection and any global business cycle effects, both at the time of matching and going forward. So if you're looking at exchange rate variability, between the difference between exchange rate variability between a treated and a control, then you don't want global effects to come into the picture. You want it to be a result of IT. Then match balance on all preconditioned country variables is key. So currently the paper produces good match balance statistics, but on some country observables the match balance is poor, and that's when you don't look at the results. You need to establish good match balance before results can be taken seriously. The last comment is that after doing good matching, establishing match balance, you can look at the difference in difference for outcome variables in event time. And that can really establish causality. So this is, you match on some precondition variables and you look at the results going forward. Some additional comments are, so currently the paper assigns a 1 in the logit for every year for an IT country, irrespective of whether that country had adopted IT in that year. So that assigns a country in the treatment group wrongly. Then some precondition variables recognized in the literature are missing, like proxy for central bank independence and fiscal discipline, output gap. I also think the precondition variables should ideally be lagged, so that you're looking at it's a precondition to adoption of IT. So they should ideally be looked at in the previous year. And this is something I said, and I'm unsure, but what the paper said was that the debt to GDP reduced more for developing countries than developed, but what you said in your presentation was opposite, so maybe you can clarify that. And going forward, I think some variable for acceptability of IT can be added in the logit, which is, so at a given time, how many countries had already adopted IT by that time. And you can rethink the measurement of fiscal discipline because it has both a structural and a cyclical component. You can study the impact on some other macroeconomic variables. Sacrifice ratio was already added, then output volatility, inflation expectations. And you can also look at the heterogeneity in results by dividing the sample on the value of lagged inflation. So what was the inflation before you adopted IT or the inflation target? So concluding, I think a time element is essential to establish causality, and there needs to be a clear question can drive the logit specification, so we can think more deeply about the LHS and RHS variables, but it's a really interesting question and it's an important addition to the literature. Thank you.